In this lesson, we're going to talk about the first part of the process of conducting a statistical study or an experiment, which is basically about collecting data. So you'll see at the top of your page, we've got a flowchart of the general steps for running a statistical study. So you start off with, of course, identifying what you want to study. And the key parts of that is you want to identify the variable or the characteristic of interest, and then what population you want to actually study. So for example, like maybe you're interested in looking at the migration patterns of blue whales. So the variable that you're looking at is the migration patterns, right? And the population is specifically blue whales. Then you want to choose a sample that's representative of the population because, like we said before, can you actually get the entire population? Often the answer is going to be no, because it's hard to get every single person or creature or whatever it is you're trying to study to give you feedback. So in that blue whale example, you might be looking at just one group or one pod that has been tagged in other studies, and you're going to use that to represent the entire population. And then you're going to go ahead and collect your data. So that could be going out onto the field, getting measurements, getting whatever. Of course, not with the blue whales, but that could also be collecting survey data. So you're going to gather lots and lots and lots of data. And often you're going to gather more data than you need, because after you collect the data, you're going to organize it, and then you're going to come up with a way to describe that data using a statistic. So you want to analyze that somehow. And often it's actually nice to get more data than you need, because sometimes as you're running through that organization process and you're trying to come up with a statistic, you might realize, oh, it was actually great to have collected this additional information because now I can use it, because what I originally thought I could use, I can't. So that's something that I learned in my grad program, is when you're going out there collect data, you often have like a one-shot situation, so you'll actually want to collect as much as possible, even if you think you don't need it, just in case. So anyway, now that you've organized your data to create a statistic, we're going to interpret that. And that's the most important part, I think. That's kind of the meat of your entire study, because you're telling what this statistic tells us. What conclusions can we draw about the population? Because that's what we're learning from everything. So that's kind of the whole cycle of a statistical study. And to start, what we need to do is we need to come up with a sample. Because again, can we get the entire population? Most likely not. So the best type of sample we could gather is a random sample. And I know I've mentioned this before, but a completely random sample means every person in the population or every creature or item in that population has an equally likely chance of being selected. So for example, if we're looking at trying to study the entire population of students at a school, how can you create a completely random sample? Well, one way you could possibly do that is you just get a list of every single kid's ID number. You run a random number generator on your calculator, on your computer, whatever, and you randomly choose like 100 of those ID numbers. Then every ID number had the same chance of getting selected, and you randomly picked 100, right? So that's a completely random sample. Now, can we always get a random sample? Not necessarily, because maybe it is really hard to reach the entire population and say, hey, I've selected you and I've selected you. Maybe some people are just not as willing to be part of a sample. So there are other types of samples that we can also use that may not be as great in terms of giving us confidence about the conclusion, but still decent to work with for our study. So if you scroll down, here's some vocabulary you want to go over. The next type of sample is called a self-selected sample. Oops. So a self-selected sample, there you go, that's what I was trying to do, is members of a population that might volunteer to be part of a study. So you might have seen these on like TV commercials where they say, call this 1-800 number if you're interested in being part of this study. That the keyword here is volunteer. So no one kind of tapped the person on the shoulder and said, hey, I'd like you to be a part of this, or no one sent them a letter in the mail saying, congratulations, you're now a part of this study. You yourself kind of called in, raised your hand, and volunteered to be a part of it because you want to be part of that study. So you often see that a lot with maybe medical studies where people volunteer to be part of a study with new medication or things like that. So the next type is called a systematic study, or excuse me, a systematic sample. What is this? Well, now a rule is used to select members of a population. For example, basically creating a rule saying, okay, I'm going to select every other person. So the key thing here is you've got to have a rule. So you might be looking at the entire population of our math class. And then we say a rule, okay, I'm just going to pick every fifth person, or I'm just going to pick everybody who has long hair. You've created a rule to kind of divvy up your population into a smaller group, okay? And there you have to think very carefully that you're picking a rule that would work to not create a bias sample, which we'll actually talk about later officially, okay? The next type of sample is called a stratified sample. So this one, a population is divided into smaller groups that share a similar characteristic, and then a sample is randomly selected from each group. So if you think about stratifying, you might think about, like filtering. So we're basically kind of clustering our population into smaller clusters or smaller groups, and then we're going to pick a random number of people from each group. So for example, if you look at, our class, we might say, let's break up our entire class as our population into a cluster of boys who have light-colored hair, boys who have dark-colored hair, girls who have light-colored hair, girls who have dark-colored hair. And then from each of those 4 groups, you're going to select like 2 or 3 people to make a random, to make a stratified sample. So again, here you're making smaller groups, and then after that, you're going to collect a randomly selected number of people from each group. So it's not completely random since you did cluster the population into smaller buckets, but then you're randomly choosing amongst those buckets. So that's an interesting type of sample. And then we have a cluster sample. So what is a cluster sample? This is a population that is divided into groups called clusters, and all of the members in one or more of those clusters are selected. So you might be wondering, wait, is this kind of like a stratified sample? Kind of, but not exactly the same, because this is when the population's clustered already, and then you're picking one entire cluster. So you might say, for example, here, let's say you're looking at an entire neighborhood, and you're going to pick a cluster. So let me actually write that down by the cluster. For example, if you're looking at an entire neighborhood, and you're trying to study the inhabitants of that neighborhood, you might have your cluster be everyone on my own block. Right, because you could argue that every neighborhood is clustered into blocks, right? So maybe your neighborhood consists of like 7 different blocks. Each one of those blocks is already a nice, neat cluster that you can work with. So we might say, okay, let me just pick my own block, and then I have one cluster to work with that cluster sample, okay? And then finally, we've got what's called a convenience sample. So this one, only members of a population who are easy to reach are selected. So here you want to make sure you see it's easy to reach. So this is probably not the ideal. I would say personally, maybe the last resort, because you're just getting people who you can kind of easily access. So here, for example, let's say you're running a lemonade stand on your block. Then you want to create a convenience sample because you're sitting out there at your lemonade stand. Maybe you're just going to work with all the cars that drive by. And then that could be a convenient sample if you're trying to maybe make a conclusion about the types of cars in your neighborhood. So here you're not actually getting out there and trying to work with creating a random sample or anything like that. You're just saying, like, I'm sitting here on the block twiddling my thumbs. I'm just going to count the cars that are passing. And that's very convenient to you because you're not going out of your way to do extra. So that would be a convenient sample. Okay? So we're going to do a couple examples of just identifying what kind of sample is demonstrated in the problem. And then we want to be careful. We want to be very careful and be able to explain why those are the types of samples, because it really helps you show that you understand the types of samples by explaining our justifications. So let's take a look at these examples. So the first one, or the scenario here, you want to determine whether the people in your neighborhood like the new social media website that provides updates for your neighborhood, I guess. We want to identify the type of sample and explain why we identified it that way. So if we look at the first one, You ask all the neighbors on the block where you reside. So what would that possibly be? Well, again, if you're looking at the neighborhood, and I mentioned this earlier, if we're just looking at on our block, then that's already kind of a cluster of the population. So this would be an example of a cluster sample. So not only are we working with that group, but we also chose to talk to all of them. That's also a key part of the cluster samples. We're actually going to use everybody from that group. Okay? If we look at the next one, you randomly select a neighbor from each block in the neighborhood. So if you think about this, this might sound like, hey, it says random. Is this a random sample? But if you look, we're selecting from each block. Each block is its own cluster, right? Its own kind of subgroup. So this is what we call a stratified sample. All right, so again, each block is its own group, its own cluster, and then here we're not using just one cluster, but we're picking a random person from every group, so that's why it's a stratified sample. All right, last one, you email a questionnaire to each, and you use only the questionnaires that are returned. So here you might be thinking, wait, isn't this like using everybody? But the key phrase here is we're using only the questionnaires that are returned. So people who return the questionnaire are people who volunteered. They were willing to be part of the study. So this is that self-selected, that volunteer situation. All right. So that kind of wraps up those three examples of identifying different types of samples. And again, you really want to think about the situation because it's not like every problem is going to say like, yes, this is stratified, right? Or here are my clusters and we're using the whole cluster. You want to interpret the situation. So we've got a few U-Try problems for you guys to work on. So feel free to pause right now and work through those problems. And whenever you're ready, hit unpause and we're going to move on to talk formally now about bias. Okay, so moving on to bias. Okay, so let's formally talk about bias. So what is bias? Bias is an error that results in a misrepresentation of the population. So that's a key word here. It's a misrepresentation. So there's an error in sampling that causes our sample to not actually be representative of a population. So for example, it's like what I've mentioned in previous situations. If you're looking at an entire school and you sample just the freshmen, so if you're trying to represent the entire high school, 9 through 12, but you only sample freshmen, you're misrepresenting the whole population by saying, hey, everyone's just a ninth grader, right? So that's a bias. So we want to always try to select what we call an unbiased sample. So an unbiased sample is representative of the entire population. So going back to, right, a high school, instead of picking only ninth graders, you're going to pick a good chunk of 9th, 10th, 11th, and 12th graders, right, to kind of represent the entire population of your school. Okay? So a sample that overrepresents or underrepresents a population is called a biased sample. So kind of going back to what we were saying before. And we want to avoid that. Because when we have a biased sample, our data is invalid, so you can run this beautiful study, this experiment, and come up with great conclusions that are consistent to your study, but if your sample was biased, we throw everything out the window, and it's a waste of your time. So that's why that random sample is important, because if we have a random sample, that could help reduce the possibility of a biased sample. Because it's not like we just conveniently asked everybody in our 5th period class who just all happens to be freshmen, right? So if you look at the next example, we want to determine the type of sample again, but now explain why it's biased. So what's interesting about this is for these two problems here, both of them are biased, and we want to identify why it's biased and then how we could fix it, right? And that would be, or think about how we might want to fix it, okay? And that would be something that you should do before you even start your study, is try to identify that you have an unbiased sample. So if you look at the first example, the principal asked students at one lunch table about the quality of food served in the school's cafeteria. So you might think, okay, well, isn't that just, you know, a nice kind of random pick? Why is it biased? Well, if you think about this situation, the principal is asking one lunch table. So that's one cluster out of who knows how many lunch tables are in the cafeteria around the school, right? And it's biased here because if you're just asking one group of students at one lunch table that maybe sits like 4 to 6 people, their opinion could be drastically different from the person of the group next to them. There's no kind of guarantee that everybody sitting at a different lunch table has a similar opinion. So that's bias, right? So then here you might want to think about, well, how many different clusters will we actually choose? So again, this is a cluster sample, biased because there's no guarantee that the opinion is actually going to be consistent throughout all of our clusters. All right. So again, we're using a little bit of common sense and logic, right? So that's that bias. The second example here, a sports announcer wants to know how often people in the town attend community sporting events. She asks every 10th person in attendance at a local soccer game. So once you see that every 10th person, you're thinking, okay, that's a rule. What is that sample called where we use a rule? It's a systematic sample. Okay, now where is the bias here? So we have a systematic sample that sounds like, hey, isn't that relatively good? We're just picking every 10th person. Well, look at the situation. If you're trying to figure out how often people in town attend community sporting events, and you ask people at a community sporting event, isn't that a bias? Because everybody who's at that local soccer game is more likely to say, yeah, we go perhaps pretty often, right? Or whatever, but you're not including people who perhaps don't go to the local soccer game but go to the local softball game or don't go to any at all. So there's a bias because you're already selecting from people who attended at least one of these sporting events. So it's not going to be representative of everybody in the community. All right. So the last example here, you are in charge of the senior class prom. You want to poll the members of the senior class to find out where prom should be held. There are 415 students in the senior class. Describe a method for selecting 70 seniors to poll. So here you can think about different types of samples and what kind of sampling you want to do. But remember, ideally, we want to try to do a random sample. So what I would do is I would think of the ideal case. How could I randomly generate 70 seniors? Well, like I said before, let's just make a list of all 415 senior ID numbers, right? Numbering them 1 to 415. Let's use a random number generator to generate 70 random numbers and then pick those 70 students. So there you go, right? Labeling each ID number 1 to 415, picking 70 random numbers from 1 to 415, and then just seeing, okay, which 70 students correspond to those numbers, and there's my random selection of 70. All right, so next up, you've got the you try problems right down here, so feel free to pause, write out your answers, and then hit unpause when you're ready to move on to talk about the experiment. Okay, so let's talk about experiments. So what is an experiment? It's very similar to what you might think about in science, right? So an experiment for us imposes a treatment on individuals in order to collect data on their response to the treatment. So treatment doesn't have to be something medical, right? It's basically something that we're trying to study. So like I said at the very beginning, if you're looking at migration patterns of blue whales, maybe you're looking at them migrate in the fall, right? So that's kind of the situation, and you're collecting data as they are migrating, right? It could be, again, someone's opinion on, right, a situation like that. Where do you want to hold senior ball sort of thing? So it doesn't have to be something clinical and something really high level. It's just we're doing something. Like how does everyone feel about building a new sports arena in the downtown district, right? So you're thinking, wait, that's the treatment affecting my hometown. What is my opinion on it? So what's that data? Okay. And it could be, again, any action. It doesn't have to be medical. So if you look underneath that, the treatment can be medical treatment, or it can be any action that might affect a variable in the experiment. So again, something like adding methanol to gasoline just to see its effect on fuel efficiency. So it doesn't even have to deal with people or animals, right? We have two types of experiments here that are important to recognize. We have a blind experiment we can talk about, where the subject does not know what treatment they're getting. So often in medicine, you might think, okay, people are either getting a placebo or the actual medicine. They don't know which. That would be a blind experiment, because then the person conducting the experiment actually does know who got the placebo and who got the actual medicine. And there's also what we call a double-blind experiment, where neither the subject or the tester know which group they're in. So someone else kind of does that for you. These are two, I guess, subcategories of experiments, because you don't have to necessarily do a blind or double-blind experiment. But why do we do these? Because it could help give us more control, right, over any kind of bias, or it helps just give us more control over the results in that sense. Okay. Next, we have an observational study. And what does this do? This observes individuals and measures variables without controlling the individuals or their environment. So you're just basically sitting back and you're seeing people or the animals or whatever in their natural state. Like, how would they act without you giving them any guidance? And you're just making observations, and you measure the variables without controlling for the individuals. So this is often used when it's difficult to control or isolate the variable being studied, or when it might be unethical especially when you're dealing with people or animals, right, to do certain treatments or withhold from them. So an example of an observational study might be, you see this happen a lot in school, right? A vice principal comes in randomly into a class, just sits in the back and watches how the class goes, and doesn't give any feedback, doesn't make any hand gestures or, eye contact with the teacher, and they're just watching the teacher in their natural environment. That would be an observational study, right? Okay, one that we often use in stats is a survey. It's an investigation of one or more characteristics of a population. And in a survey, every single member of the sample is asked to answer at least one question, right? And you get these a lot, even, every year from the district or the school. They may ask you to do a survey about how school's going or how you're feeling emotionally, right? So that's a survey. And then a simulation, which we talked about before, is a model that would represent the situation. It doesn't actually have to be the actual situation or actual conditions of the situation. It could be, like we said before, using a dice to show 6 different outcomes. That's simulating the population proportion situation, right? If you're saying, like, 40% of the people tend to like fruit and the other 60 don't, you can say, okay, well, these numbers correspond to the 40%, these numbers correspond to the 60% or whatever, and go that way with dice. It could be a computer-generated simulation, right? It's often used to, in a situation where it's impractical to actually do the study yourself, or it's dangerous, right, to create it in real life. So you might also see, like, flight simulations, and they actually do simulate the real life situation. So you can have those simulations as well. It doesn't necessarily have to be dice or, flipping a coin. It could be something more intensive. But it's, again, when it's kind of not feasible or not practical or too dangerous to do it out in real life. Okay? So these next examples are just identifying the method of data collection and explain why we identified it as that. So is that an observational study, a simulation, a survey, right? That's what we're looking for. So this first example says a teacher records how many students enter the classroom and turn in their homework before sitting down at their desks. What's important here is this teacher is just watching, right? The teacher's not giving any instruction. So when you're not kind of interfering with people doing what they're doing, that's what we call an observational study. All right, so again, the key thing here is the teacher did not interfere. There's no treatment being done. If you look at the second example, a manager uses a computer program to predict how many defective products can be expected on a particular assembly line. So the key information hopefully you're getting from that situation is we're using a computer program and we're trying to predict. So we're not actually going out there and counting how many defective products we have in real life. We're trying to predict using a simulation, okay? So we're using the computer to reproduce the conditions. So this is a simulation. So there we go. Those are those 2 examples. So the last one that we actually haven't talked about here is a survey, because we actually want to talk a little bit more about surveys. So if we scroll down, if you look down, some key things to think about when dealing with a survey. So when designing a survey, it's actually really important to think about the wording. So you can spend a lot of time designing a survey. When I was in grad school, we spent, I think, 3 hours working on a 5-question survey that we were going to use for teachers, because you have to be very careful. You don't want to end up with biased results, because depending on how you word the question, you might be accidentally or intentionally leading people to give you a specific answer. And then if you do that, we've created a biased question, which gives us biased results, which is then results we can't use that are invalid. So we want to avoid these questions that encourage any particular response, right? Do not provide enough information, are too sensitive, or address more than one issue, because we want them to be actually short and to the point. So we want to look out for that. In this last example, let's analyze a survey question. We have a survey question that asks, should the town build a playground and a dog area in the park on Main Street? So we want to figure out why this may be biased or introduce bias in the survey, and then how can we correct it? Because remember, we want to create unbiased results so we can actually have a valid study. So in this situation, it's not really encouraging any particular response. It's not saying like, would it be good for kids or to have a playground or something. That's not worded very well, but you know, it's kind of leading people to say, yes, we want the playground. We don't want to lead into that. So we don't have that. It gives us enough information. So we know, okay, we're looking at a playground and a dog area in the park on Main Street. So that's good. Are they too sensitive? Well, these aren't really sensitive situations, right? It's not really asking people about personal information or sensitive topics. But if you look at that last bullet point, address more than one issue, it's totally addressing more than one issue because a playground and a dog area are two different things. So to correct it, we might just separate that into two different questions. One separately about should they build a playground, and a second question about should we have a new dog area. So there you go. So again, when you're trying to determine if you've got a biased question, try to at least go through those 4 bullet points, right? See if it's kind of eliciting a specific response, right? See if it has not enough information, too sensitive, addresses more than one issue. Okay, so we're going to wrap this up with this last page of U-Try problems. So pause, and whenever you're ready, we're going to start back at the beginning and go over all these answers to the U-Try problems. Okay, so let's scroll back up and check those U-Try problems. So here we go. So we're identifying what kind of sample was listed and then explaining why. So go ahead and look at those and hopefully that all makes sense. Right, we've got systematic, then self-selected, or you can say volunteer, convenience, and then stratified. Okay, then moving down, the next set of U-Try problems are right here, talking about the type of sample, but not really explaining why the sample is that type of sample, but explaining why it's biased. Because remember, we want to avoid biases. So with that first one, the online poll about bullying, if someone's going to go online and respond to the poll, they probably have a very strong opinion about bullying. So you're kind of ignoring the population who maybe don't have as strong of an opinion or not as motivated to get their opinions out there. So you are alienating a portion of the population. So that would be biased versus like just cold calling 20 random numbers, and then you might get people who are very opinionated and who are like, well, I haven't really thought about it before, and you're getting the diverse array of opinions. Okay, and then with this convenient sample, again, it's biased because you're not letting other people have a chance, and you might even think, hey, people who are in computer science classes might access the internet really often because they're interested in developing websites or they're interested in things that are online, so that could also be a potential bias, but again, you're not giving everyone a chance to answer. And then that third one here, I basically use the same kind of format I did with the example, and you guys could have something different. But remember, ideally, we want to aim for a random sample. So your description of a method should be something that would give us a random sample. So again, I'm using that random number generator. All right, and then the next set of U-Try problems were right over here. So starting with, this is the last page, right, identifying the method of collecting data, explaining why we knew that. So if you're just asking every 8th person, we're asking a question, right? So that means it's a survey. As long as we're asking one question or more, we're conducting a survey. And this would be a survey based on a systematic sample, if you're curious about that. Right? A park ranger measures and records the heights of trees in a park. So this park ranger is not doing anything, not applying, any weed killer, fertilizer, not pruning, not interfering in any way, not applying treatment. So it's an observational study. And this last one would be a simulation, because we're using a program to kind of generate a model. So we're not actually going out there and testing everybody day after day, month after month to get the actual spread data. We're simulating it with software. And then finally, last one, read that question carefully. If we're asking, do you agree that our school cafeteria should switch to a healthier menu, that's kind of leading people to say yes, because you're asking, do you agree, which means you're assuming they agree. Or that may sound like the assumption. So that could lead people to say yes when they may not actually believe that. So you want to reword that and perhaps correct it, say, and ask, should the school switch to a healthier menu? And then you can say yes or no, why or why not from that. And then it's not as leading, and that could be a slightly less biased question, right? You can, of course, debate whether or not you want to use the word healthier, because sometimes people think, oh, when you put that in, people think, of course, we should be healthier, when they may not actually believe that. But anyway, that's another point up to debate. But this is at least one way to fix that leading part of do you agree or not. And you can see how these conversations can go on for a long time. Like I said, in my grad program, we argued about like 2 words for an hour to figure out if that's the best way to ask the question, because often you get one shot at the survey. You can't say, well, that was a biased question, let me just go tap everyone again, and they may not be as willing to answer it again. So good things to think about when you're doing a statistical study. Okay, so that wraps up talking about types of samples and collecting data. So if you have any questions, please ask. Otherwise, thank you for listening.